My name is Princess Di Navarro. So we are the group 4 and our topic is all about the organization of test data using tables and graphs. So test data are better appreciated and communicated if they are arranged, organized, and presented in a clear and concise manner. So good presentation requires designing a table that can be read easily and quickly. So tables and graphs are common tools that help readers to better understand the test results that are conveyed to concerned groups like teachers, students, parents, administrators, or even the researchers, which can be used as basis in developing programs to improve learning of the students. So to begin with this lesson or discussion, let's take a look at this table. Table 7.1 is considered a group of raw scores recorded from a summative test administered to 100 college students at the Teacher Education University. So, how do we organize and present and group data through tables? So as you can see in Table 7.1, the test scores presented as a simple list of raw scores. So raw scores are easy to get because these are scores that are obtained from administering a test or questionnaire or any inventory rating scale to measure knowledge, skills, or other attributes of interest. So, the arrangement of the scores on this table are not organized or they do not look interesting nor meaningful. So, now, let's take a look at this following table. As you can see, they are now arranged from lowest to highest. So table 7.2 is a simple frequency distribution that shows an ordered arrangement of scores, which is better than the random arrangement of raw scores in table 7.1. So the listing of scores can be in descending or ascending order. So you create this table by simply tallying the scores. So there is no grouping of scores, but a recording of the frequency in a single test score. So with this table, you will know in a second what is the highest and the lowest score. So the corresponding counts for each score. The frequency and percent columns give more specific information on the number and percentage of students who got a specific test score. So, Table 7.1 doesn't provide. Moreover, you can roughly estimate the concentration of scores with this frequency table. So the cumulative percentage in the last column calculates the percentage of the cumulative frequency below a certain score in the dataset. So for example, in the sixth row, the test score of 35 has a corresponding cumulative percentage of 13. So it means that 13% of the class obtain a score below 35. So conversely, you can also say that 87% of the scores are above 35. So as you can see in table 7.2 is more informative than 7.1, but you may still find the presented data lengthy. So let's take a look in table 7.3 that would be discussed by Kenneth Piodena.
Good day to everyone. My name is Kenneth Piodena and my topic is all about the frequency distribution of group test scores. This is the continuation of how we will make a table about the test that has more items and examinees or when scores are more spread out. So let's start. We will start. Let's define first what is frequency distribution of group test scores. This is a frequency distribution where the classes are ranges of possible values. This is also another way of arranging data by grouping the observations into intervals and tabulating the frequencies for each interval. Dito sa table, makikita natin na may 5 column which are class interval, midpoint, frequency, cumulative frequency, and cumulative percentage. Ang class interval daw po ay usually given na. Halimbawa po dito sa table, ang class interval natin ay 12 because nahati-hati na siya until 12 place. Paano naman siya nahati-hati? Nahati po siya sa pamamagitan ng pag-solve sa size of the class intervals or ang I. Dito sa table is ang size of the class interval is 5. So, paano ba natin makukuha ito? Dito, gagamitin natin ang formula na I, size of class intervals equal to highest test score minus lowest test score and divided by the number of classes. Ano naman ito gamitin? So, babalik tayo sa table ng frequency distribution of test score at hahanapin natin ang highest test score which is the 79. Tapos, hahanapin naman natin ang lowest test score na 21. I-divide natin ito sa number of classes which is 12. So, 79 minus 21 is equals to 58. 58 divided by 12 is equals to 4.8 or rounded up into 5 because dapat naka-rounded up always. Ito na nga po ngayon ang magsisilbing batayan po natin sa bawat hati. Ang bawat hati po natin ay tig-5 number sa loob ng bawat class. Makikita natin sa table ay nahati na sa 5. Ito ay ang 22 to 24, 25 to 29, 30 to 34, 35 to 39, and so on and so forth. Hanggang sa makaabot sa limit natin o ang highest test score na 79. Tapos na tayo sa class interval, dumako naman tayo sa susunod na table which is ang midpoint. Ito ay ang connotes of middlemost score which is halfway between the exact limits of this interval. This is often used for estimating the average value in each class. Makukuha natin ang midpoint sa formulang ito. Class midpoint equals to lower limit plus upper limit divided by 2. Halimbawa na lamang po sa class interval natin na 20 to 24. Midpoint equals to 20 plus 24 divided by 2. Ang 20 plus 24 is total is 44. Divided by 2 is 22. Ang 22 ay ang ating midpoint. Ganon rin ang ating gagawin sa iba pang class interval para makuha natin ang midpoint. Ang pangatlong column naman ay ang F or ang frequency. Ito ay ang number of data values of test scores in the categories of frequency distribution. Makukuha natin ito sa pamamagitan ng pagtali. Balikan natin ang table ng frequency distribution of test scores para makuha natin ang F. So, sa class interval natin na 20 to 24, ang F niya ay 1 kasi isa lang ang may nakakuha ng test score na may class interval na 20 to 24, which is ang 21. Dito naman tayo sa class interval na 30 to 34, ang F niya ay 9 kasi may 9 na student na nakakuha ng test score na isang 30, isang 32, 6 na 33, at isang 34. Ganun din ang gagawin nyo sa iba pa hanggang sa makaabot tayo sa highest test score. At pagkatapos makuha ang lahat ng frequency, ay ito-total natin ito at dapat same ito sa total natin. Ikaapat naman na column ay ang cumulative frequency. Ito ay the sum of the frequency of given class and all previous classes. The cumulative frequency of the class is equal to the sample size. Makukuha natin ito sa pamamagitan ng pag-add natin sa cumulative frequency sa susunod na frequency. Halimbawa dito sa class interval na 20 to 24, ang frequency niya ay 1. So wala naman tayo number na kasunod sa kanya. So ilalagay natin ito automatiko. Ang susunod ay i-add natin ang 1 sa susunod na frequency, which is ang 0. So 1 plus 1 is equals to 1. Ganun din ang gagawin natin sa iba. So dito 1 plus 9 is equals to 10, and so on and so forth. At ang huling cumulative frequency ay dapat equal sa total ng frequency. Ang panghuling column ay ang cumulative percentage. This is to calculate the percentage of the cumulative frequency within each interval. Para makuha ang cumulative percentage ay sa pamamagitan ng ang cumulative frequency ay i-divide natin sa n, which is ang total ng result ng frequency natin. And then, i-multiply natin ito sa 100. Dito sa ating table, katulad pa rin ng frequency, ang cumulative frequency ng 20 to 24. So, 1 divided by 100 is equals to 0.01. Times 100 is equals to 1. Sa susunod naman na row ay kunin natin ang cumulative frequency, which is 1 pa rin. So 1 pa rin ang sagot niya katulad ng nauna. Dito naman tayo sa cumulative frequency na 10. 10 divided by 100 is 0.1 times 100 is equals to 10. Ganon rin po ang gagawin natin sa iba.
Thank you, Ms. Pidina. Hello everybody, my name is Nofame Razo, and now let's talk about on how do we present the test data graphically. You must be familiar with the saying, a picture is worth 1,000 words. In a similar vein, a graph can be worth 100 or 1,000 numbers. So, the use of tables may not be enough to give a clear picture of the properties of a group of test scores. If numbers presented in table are informed into visual models, then the reader becomes more interested in reading the material. Consequently, understanding of the information and problems for discussion is facilitated. Graphs are very useful for the comparison of test results of different groups of examinees. There are many types of graphs, but the more common methods of graphing a frequency distribution are the following. First, histogram. A histogram is a type of graph appropriate for quantitative data such as test scores. This graph consists of columns, and each has a base that represents one class interval, and its height represents the number of observations or simply the frequency in that class interval. There are statistical software that are available to help construct histogram and other form of graphs. More important than longhand procedure in constructing histogram is how to call information from the graph. Look at the graph in figure 7.1, histogram of test scores of college students. The graph was automatically generated with the use of a statistical software. In this case, a statistical package of social sciences was used. Basic steps in SPSS application including the following. Step 1. Open the data editor window. It is understood that the data has already been entered into the data editor following the data entry process. The assumption here is that you already know the basic of entering data into the statistical program. Step 2. On the menu bar, click Analyze, then go to Descriptive Statistics, then to Frequency. This brings up the Frequency dialog box as seen below. As you can see on the image, it shows the data editor. In the next line of the image, you see there is a row on File, Edit, Data, Transform, Analyze, and the last one is the graphs. Step 3. To make a histogram, do the following steps. First, open the data editor. Second, on the menu bar, click on Graphs. Next is the Legacy Dialogues, followed by Histogram, and the last one, click OK. You will get this by looking at the picture. So, after you have clicked OK, the desired histogram will automatically be shown. The same process will be followed in generating other types of graphs. You may also try to organize the data using your knowledge in Excel. The following web references can be useful for those who have never used SPSS. You can try to open this link, the www.spss.tutorial.com. You know that there are more you can access. Just search on the internet and find it with yourself because there are more tutorials available online. I will give it to Ms. Reganion to continue our report. Thank you, everyone.
Good day, everyone. I'm about to continue the report of Ms. Razo. By the way, I'm Ana Marie Reganion, and my report was all about frequency polygons. Values will be the X and F. This is only a short presentation, so without any further ado, let's get started. Frequency polygon is a line graph of class frequency plotted against class midpoint. It can be obtained by joining the midpoints of the tops of the rectangles in the histogram. When we say histogram, this is a graphical representation that organizes a group of data points into user-specified ranges. Similar in appearance to a bar graph, the histogram condenses data series into an easily interpreted visual by taking many data points and grouping them into local ranges or bins. Frequency polygon, this is also used for quantitative data, and it's one of the most commonly used methods in presenting test scores. It's the line graph of a frequency polygon. It is very similar to a histogram, but instead of bars, it uses lines to compare sets of test data in the same axis. Figure 7.2 illustrates a frequency polygon. In a frequency polygon, you have lines across the scores in the horizontal axis. Each point in the frequency polygon represents two numbers, which are the score in the horizontal axis and the frequency of that class interval in the vertical axis. Frequency polygons can also be done superimposed to compare several frequency distributions, which cannot be done with histograms. You can construct a frequency polygon manually using the histogram in figure 7.1 by following these simple steps. So the first one is, locate the midpoint on the top of each bar. Bear in mind that the height of each bar represents the frequency in each class interval, and the width of the bar is the class interval. As such, the point in the middle of each bar is actually the midpoint of that class interval. In the histogram on figure 7.1, there are two spaces without bars. In such case, the midpoint falls on the line. The next one is draw a line to connect all the midpoints in consecutive order. The last one is the line graph is an estimate of the frequency polygon of the test scores. Following the above test, we can draw a frequency polygon using the histogram presented earlier in figure 7.1. Frequency polygons can also be drawn independently without drawing histograms. In your algebra, you need an ordered paired x and y to graph a point in the coordinate system. For this, the midpoint of the class intervals are used to plot the points. The midpoints will be the x values and y will be the respective frequencies in each class interval. For data in Table 7.3, the x and y values will be the x and f. And for the continuation and more information of my report, let's hear from Miss Ruby Rose or more. Once again, thank you so much for listening.
Good morning to each and everyone. By the way, my name is Ruby Rose Moore, and this time I am about to explain to you the number 3 in common methods of graphing a frequency distribution, which is the cumulative frequency polygon. So cumulative frequency polygon means that this graph is quite different from a frequency polygon because the cumulative frequency are plotted. In addition, you plot the point above the exact limits of the interval. As such, a cumulative polygon gives a picture of the number of observations that fall below a certain score instead of the frequency within a class interval. In Table 7.3, as you can see, the cumulative frequency is on the 4th column. In the 5th column is the conversion to cumulative percentage. A cumulative percentage polygon is more useful when there is more than one frequency distribution with an unequal number of observations. The following figures show the cumulative frequency polygon and cumulative percentage polygon respectively of the data in Table 7.3. These cumulative frequency polygons are useful to obtain a number of summary measures. The graphs display ogive curves. Again, the images are computer-generated output using a statistics software.
Pleasant day to each and everyone. By the way, my name is Michael John Rosas, a third-year B.Ed student of Ramon Magsaysay Memorial Colleges. And today, we're gonna talk about bar graph. Yes, bar graph or bar chart. So, what is bar graph? So, this graph is often used to present frequencies and categories of a qualitative variable. A bar chart or bar graph is a chart or a graph that presents categorical data with rectangular bars with heights or length proportional to the values that they represent. The bars can be plotted vertically or horizontally. So, as you can see the picture, that is the example of bar graph. As you can see again that they have different heights of bars and different color because each bar represent one data. To monitor the improvement or deterioration of the presented data. So, types of bar graphs. So, first is simple graph, second is horizontal graph, third is double graph. So, let's discuss first the simple graph. So, simple graph or simple bar chart is used to represent data involving only one variable, classified on a spatial, quantitative, or temporal basis. So, this type of graph are very conventional among the other types of bar graph because this graph represent data only one variable to monitor the improvement and deterioration of the represented data. Second is horizontal graph. So, horizontal graph, a horizontal bar chart is a graph in the form of rectangular bars. The bar chart title indicate which data is represented. So, horizontal graph and simple graph are the same. The only difference between the two is horizontal graph are created horizontally, not vertically. They have same purpose to monitor the improvement and deterioration of the presented data. Lastly is the double graph. So double graph is a bar graph that displays two sets of data. So this graph has a big difference among the two, the horizontal and vertical graph, because double graph has one data with two variables, and they have the same purpose again, to improve to monitor the improvement or the deterioration of the represented data. So that's all my report, and
So
thank
good
you.
morning everyone, my name is Joy Misagayno and my topic is all about box whisker plot and the pie graph. So box whisker plot defined as a graphical method of displaying variation in a set of data. Box whisker plots are very effective and easy to read as they can summarize data from multiple sources and display the results in a single group. So, this is a very useful graph depicting the distribution of test scores through their quartiles. This first quartile or Q1 is the point in the test scale below which 25% of the scores lie. The second quartile is the median, which defines the upper 50% and the lower 50% of the scores. The third quartile is the point above which 25% of the score lies. For example, the data of the test scores of 100 college students produce this image using the box plot approach. Looking at the box plot graph, the shaded rectangle represents the middle 50% of the test data. The line that divides the rectangle is the median, and the rectangle is referred to interquartile range box. So the top side of the rectangle is the Q3 or third quartile, and the bottom side is Q1 or first quartile. As such, this type of graph will help readers easily see where the scores are concentrated or how the scores are distributed and divided into quartiles. So, what scores separates each quartile as well as the minimum and maximum values. So, the whisker are the lines that extended from either the top side or lower side of the box. This whisker represents the range from the bottom and the top of 25% data values excluding outliers. It is the number you see outside the whiskers. So outliers can send important message about the certain phenomenon. For example, if you want to exempt students from a final examination, the outliers at the top will indicate who can be exempted. At the same time, those on the other extreme might need more attention and assistance to perform in the class. Next is pie graph. So, pie chart displays data, information, and statistics that easy to read and like in a pie slice format with varying slice sizes telling you how much of one data element exists. The bigger the slice, the more of that particular data was gathered. One commonly used method to represent categorical data is the use of a circle graph, and we've learned in basic mathematics that there are 360 degrees in a full circle. The categories can be presented by the slices of the circle that appear like a pie. It is called pie graph. So the size of the pie is determined by the percentage of students who belong in each category. For example, in a class of 100 students, results were categorized according to different levels, which showed that 10 students or 10% scored above average, 40 students or 40% is the average, 30 or 30% below average, and 2 to 0 is 20% poor. These percentages will be indicative of the size of the slices in the full circle. So, the simple calculation shows that 10% of 360 is 36 degrees,
40% of 360 is 144 degree, 30% of 360 is 108 degree, and 20% of 360 is 72. So the total of percentage is equal to 360 degree. You can use an ordinary protractor or compass, and you need to label each portion of the pie with different shades to indicate the categories and label of the whole chart. So that's all my report. Thank you and God bless.
Good morning. By the way, I'm Darlene Jiswa, and today I will going to report my topic was about what graph is best. So no one can give a definite answer to these questions. We cannot say what is the best. So first is the histogram. So the histogram is the easiest in many cases of quantitative data, but it may not be appealing if you want to make a comparison of the performance of two or more groups. Second is the bar graphs. So the bar graphs work well with qualitative data if you want to compare the performance of the subgroups of examinees. Next, frequencies and percentage polygons are useful for treating quantitative data. The cumulative frequency and percentage polygons are valuable for determining the percentage of the distributions that falls below or above a given point. Next, the cumulative percentage polygon becomes more useful for the comparison of groups with an equal number because frequencies have been converted into percentage. The box and whisker plots are not very popular because they can be difficult to construct without statistical software. However, this can provide interesting and salient information to audience about test data other graphs cannot provide, and some that choice will depend on your purpose and what you want to convey. So next is what are the variations on the shapes of frequency distributions. As discussed earlier, a frequency distribution is an arrangement of a set of observations. These observations of the field of education or other sciences are empirical data that illustrate situation in the real world. With the world population reaching 7.6 billion, you can imagine hundreds of possible frequency distributions representing different groups and subgroups taken from an infinitely large population. It is reasonable to expect that there will be variations in the shapes of frequency distributions. Researchers, scientists, and educators have found that empirical data, when recorded, fit the following shapes of frequency distributions. And that's all my report. Thank you for watching and listening. I hope you learned something from my part, and just amazed when seeing will continue to report.
Good day everyone. The topic was assigned to me is keyword or skewiness. So now, Skeward said, in a symmetrical distribution, mean and median are very close to each other, so you can use either of them as a presentation of the average. A positively skewed distribution is the distribution that is composed of mostly small observation in a few relatively or extreme large observation. In short, it talks about the mean, mode, and median. As you can see, mean and median are very close because they are the same, so it depends to you what you want to use, either of them as representations of the average. So next slide, part of the skewed, which is symmetrical distribution, positively skewed, negative skewed, and rectangular distribution. Next slide. Now, symmetrical distribution. A symmetrical distribution is one where the mean, mode, and median are all equal. In a such distribution, the intervals of gains or losses exhibit the same frequency. For instance, if we have a symmetrical distribution with a mean return of 0, then the frequency of losses between -2% and -1% will be equal to the frequency of gains between 1% and 2%. Symmetrical is one where you can see all of them in equal. Look at the chart. chart, observe it. Next slide, positively skewed. Positively skewed, this is the tendency of given frequency curve learning towards the left. Conversely, the tail extends to the right. In this distribution, you should note the following. The mode is bigger than both the median and the mean. The median always occurs between the mode and the mean, and the observation below the mean and more than those above. Look at the chart. You will see the bigger of mode compared to the median and mean. Next slide, negatively skewed. In negative skewed, this is a frequency curve where the long tail extends to the left. It has the following characteristics. The mode is usually bigger than both to the median and the mean. The median is found between the mean and the mode. The observation above the mean are usually more than those below it. In the chart, mode is usually bigger than both of median and mean. The median found in mode and mean. Positive and negative are different in their function or direction but the same purpose in terms of getting average in one problem. In positive, developing was the good example and developed to the negative, for example, developing the country. Last slide, rectangular distribution. In a probability theory and statistics, the continuous uniform distribution or rectangular distribution is a family of symmetric probability distributions. The distribution describes an experiment where there is an arbitrary outcome that lies between certain obtained. So, in rectangular distribution, this is where all the outcomes are equally likely to occur. And that's all my report. Thank you.
Hello everyone, good morning. I am Joanna K. B. Somadra and I will show to you that another way of characterizing frequency distribution is with respect to the number of peaks seen on the curve, and this is still part of the skewness. Now, in figure 7.12, this is a unimodal frequency distribution. You see that the curve has only one peak. We refer to the shape of this distribution as unimodal. From the word uni means one. Unimodal distribution is a distribution with one clear peak or most frequent value. The value increase at first. So, tataas yung value sa una, rising to a single peak where they then decrease. Makakabuo ng isang peak after tataas, bababa na naman. The normal distribution is an example of a unimodal distribution. Kagaya sa inyong nakikita, this is a normal distribution. The normal curve has one local maximum peak. Iisa lang talaga yung curve pag normal and when it is a unimodal. Now, for another graph. There are two peaks appearing at the highest frequencies. This is figure 7.13, a bimodal distribution. We call this bimodal distribution for those with more than two peaks. We call this multimodal distribution. Note that a bimodal distribution is a specific type of multimodal distribution. Example of bimodal distribution in test scores. Suppose a teacher gives an example to his class of students. Some of the students studied for the exam while others did not. When the teacher creates a graph of the exam scores, it follows a bimodal distribution with one peak around low scores for students who didn't study and one peak around high scores for students who did study. So, by the help of the graph, the teacher can easily recognize the result. In addition, unimodal, bimodal, or multimodal may or may not be asymmetric. I mean symmetric, as we look back at the negatively skewed and positively skewed distributions in figure 7.9 and 7.10, both have one peak. Hence, they are also unimodal distributions. As you can see, each have only one peak. That's why, as a result, it's a unimodal. Now, let's proceed to cortices. It is another way of differentiating frequency distribution. Consider now the graphs of three frequency distribution. This is the figure 7.14 frequency distributions with different cortices. We will find out what cortices is and what are the three types, as you can see in the graph by the different line with different letter. Okay, what is cortices? It is the flatness of the distribution, which is also the consequence of how high or peak the distribution is. This property is referred to as cortices. It is to measure kung hanggang saan at kung gaano kataas yung distribution. Another definition, cortices is a statistical measure used to describe the degree to which scores cluster in the tails or the peak of a frequency distribution. The peak is the tallest part of the distribution and the tails are the end of the distribution. And there are three types of cortices. We have platycortic, mesocortic, and leptocortic. This is the example of every types, as you can see in the picture. Now, we will find out those letters in the graph if what type is it. Let's start with the X. It is the flattest distribution. It has a platycortic, platy meaning it is broad or flat distribution. Look at the graph and observe the curve. Now, for Y. Y is the normal distribution and it is a mesocortic. Meso meaning intermediate distribution. Look at Y in the graph. It is bell-shaped. And for Z is the steepest or slimmest and is called leptocortic. Lepto meaning narrow distribution. Look at the graph. As you can see, Z is the sharply peaked with heavy tails. And that's the end of our report. If you have corrections and knowledge about our report, we are open and willing to be corrected. Thank you so much and God bless everyone.